weekend. Today we're going to talk about converting to slope-intercept form. Today we're going to be using free-form notes, so just make sure your heading at the top is correct. Don't worry about setting it up for Cornell notes or any other style. So at the very top of the page, please go ahead and write converting to slope-intercept form. Below that, write the date. If you have my class on Monday, it's the 19th of October. If you have me on Tuesday, it's the 20th of October. Okay, our first heading is converting equations to slope-intercept form. Remember, our slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. Okay, so just a quick reminder, we graphed lines last week that were already in slope-intercept form. It makes it really easy because you identify the y-intercept, you put a dot on the graph at that point, and then you use the slope to put additional points on. So today we're really talking about equations that aren't already in slope-intercept form, how we can convert them back to slope-intercept form so we can graph the equation a little bit easier. So basically step 1 and 2 is simplify. So we're going to treat this like we would a normal equation for the most part. There's some caveats at the end. We're going to change it up a bit. So we're going to start by using the distributive property to remove any parentheses. So take whatever's on the outside of the quantity, multiply it by what's on the inside of the quantity, get rid of those parentheses. After that's done, go ahead and combine all like terms on the same side of the equal sign. So like I said, step 1 and 2, basically simplifying. All right, step 3 changes a little bit because now we're not trying to isolate the x variable as we normally do, because when you're graphing a line, you need both the x and y variable in the equation. So we have to essentially move everything away from the y. That's what this word isolate means, so we want to get it by itself. So we're going to isolate the y by balancing the equation using properties of equality. Properties of equality is a fancy way of saying inverse operations. So if we have a constant next to the y, we have to move it away from the y. If the y has a coefficient, we have to go ahead and divide both sides of the equation by whatever that coefficient is. Obviously, we have to use the properties of equality in the opposite order. Keep that in mind, just like you're solving an equation normally. All right, we'll definitely do an example of that down below. Finally, the last step is to rewrite the equation in slope-intercept form. So for example, maybe you end up something where you have the y-intercept before the slope. Just go ahead and flip it, put it in the right order, while also maintaining that isolation of the y variable. All right, if you want to pause for a second now and write down the steps, that'd be great. But I am going to go ahead and move on to examples. All right. Okay, our first example is we have negative 5x plus 2y equals negative 20. Now this equation is in what we call standard form. Standard form is when you have the x and the y on one side of the equal sign and a constant on the opposite side. Okay, so I want to get this y by itself. So the first thing I'm going to do is add 5x to both sides. Okay, so far so good. That goes away, and on the left side I'm left with 2y, and on the right side I'm left with negative 20 plus 5x. Let me go ahead and make this a little bit thinner line. Okay, now I'm basically done. Only thing left on the left side with that y is the coefficient of 2. I want the coefficient to be 1, or I want y to be a naked variable, so I need to divide both sides by 2. Now, left side's easy. This goes away. Then we are left with y equals negative 20 divided by 2 is negative 10. 5 divided by 2, I could write 2.5 down, but since we're going to graph this line, I could say 2 and 5/10, I could say 2.5, but really I think this is the best option. Just write it as 5/2 x. All right, so our equation is y equals negative 10 plus 5/2 x. Now we're almost done, but we want to write that in slope-intercept form. This is technically slope-intercept form, but I want you guys to get in the habit of writing it down with the slope, in this case 5/2, in front of the y-intercept. Okay, so now we have an equation in slope-intercept form, so we know our first point on the graph is going to be 10 below the origin, and our slope is going to go up 5, right 2. All right, there's our first example. Okay, this next one's also going to be in slope-intercept, or point-slope form. Oh my goodness, not point-slope form, standard form. We have the x and the y variable on one side of the equation, and then we have a constant on the opposite side. So once again, I'm trying to isolate the y variable. So what I'm going to do here is subtract x on both sides. All right. So this goes away. X minus x is 0. So I'm left with negative 3y equals 9 minus x. Now in this case, I'm going to go ahead and put a 1 in front of that x as a reminder. I find it's helpful for students to have a coefficient visible just to remind themselves that there is a number there. Now I'm left with the coefficient of y to be negative 3, which means I have to divide both sides by negative 3 to isolate that y. So over here, my y is isolated. 9 divided by negative 3 is negative 3. Negative 1 divided by negative 3 would be positive 1/3. So this converts to positive 1/3 x. Now, once again, my y-intercept is in front of my slope, so I want to go ahead and switch that around. So I'm going to rewrite my equation to be y equals 1 over 3x minus 3. You notice when I rewrote the equation, I don't have a plus sign there anymore because this plus sign really indicates that this 1 over 3 is a positive. This is definitely positive. So I just need to make sure I include that negative sign in front of the 3. So when I'm done, now once again, I have an equation that's in slope-intercept form. I know I'm going to put the first point on the graph 3 below the origin, and we're going to go up 1 unit as we move 3 to the right. Okay, that's our last example of standard form to slope-intercept form. Now we're going to move on to point-slope form. So point-slope form basically has a couple different variations. This is a form in which you're given the slope from the get-go and you're given a point and you can kind of plug information in from there to make a line as well. It's still easier, generally speaking, to go ahead and graph it using slope-intercept form. So this time I'm going to have to distribute first. I'm going to multiply that 1/2 into the equation, right? Now you notice the y is already by itself, so really all I have to do here is simplify the right side and I'm done. So 1/2 times x is 1/2 x, easy money. 1/2 multiplied by negative 4 is negative 2. Go ahead and combine like terms, and I'm done. So there's only one term with an x, so that's done. Negative 1 plus 2, negative 1 plus 2 would be negative 1. And there you go. I already have my equation in slope-intercept form. I'm just going to write it again over to the right. Y equals 1 over 2, or 1/2 x minus 1. Now I have an equation that can be easily graphed. Okay, last example. Like I said, if you need to pause or go back and review any of these, feel free to do so. You can do this at your own pace. Okay. Same basic idea. I need to simplify the right side. So I'm going to distribute that in. After I'm done distributing, I have negative 3x. Negative 3 multiplied by negative 2 is positive 6. Okay, now only thing I have left to do is to subtract the 4 from both sides in order to get the y completely isolated. Okay, so that goes away and I'm left with y equals negative 3x plus 2. So once again, I went from a point-slope form to a y-intercept, slope-intercept form. Just going to rewrite it so it's clear here. Y equals negative 3x plus 2. All right, that's what we'll be working on today. So I hope you have the time to watch this before class. If not, I'll give you guys a little bit of time at the beginning of class to kind of go through it. And hopefully we can spend most of our time together kind of doing example problems and working through any misconceptions. All right, thanks for watching. Talk to you guys later.